Hey juniors, Mr. Shelton here, your last SAT MME video that you're going to have to watch for Earth Science. Hold on, don't cry, dry your tears. This one's my best one. This one is about weather and fronts, and it's a review for what we have to do for the SAT MME, and it's something that it seems is repeated year after year. So I encourage you to really focus in on what we're doing here. You see the weather map that I've drawn for you at the top. This is the United States. This baby's hand-drawn, just special for you. First, we're going to talk about what low pressure is, and then we're going to talk about what high pressure is. I'm going to review for you what cold fronts are and how they operate. I'm going to talk to you about what warm fronts are and how they operate. And then we're going to actually talk about the mechanisms of low pressure and associated fronts and high pressure and the associated weather that goes with that. So buckle in. This ought to be super interesting. All right, so first move over to the middle right of your paper, and we're going to talk about low pressure and high pressure. Low pressure is signified on a weather map by a big block L. So this is low pressure. It's red on a weather map. Low pressure has three characteristics. The first characteristic is that air in a low pressure system is rising. You know, I hope you remember, that rising air also leads to the formation of clouds. So would you also write down that where we have low pressure, we have clouds forming? And the last thing that comes with low pressure is that low pressure rotates counterclockwise. So would you write that down? Counterclockwise rotation. So when we have weather, weather is generally associated with low pressure. The other type of pressure that we have to talk about today is high pressure. So those are signified by big block capital H's, and they are blue on a weather map. So this is high pressure. There are three associations with high pressure. The first is air in high pressure is sinking. If air is sinking, we can't have clouds. So what we have is we have clearer skies. That's not to say that you won't have puffy cumulus clouds floating around, but it's not going to be cloud cover. And the third thing that we have with high pressure is we have a clockwise rotation. Clockwise rotation. And we're going to talk about how high pressure brings us nice weather. So you want to see big blue H's setting over top of your area. When you have that, you're generally going to have good stuff going on. So now what we're going to talk about is how fronts are associated with only high and low pressure. So we're going to first talk about cold fronts, and then we're going to talk about warm fronts. And we're going to talk about the kinds of clouds and the kinds of weather that come with them. So float down to the bottom left side of your paper. So what we have here, if we could look at the side of cold air moving into warm air, right? This is a side view. So we have cold air at 65 degrees driving into warm air at 85 degrees. For the purposes here, we're going to say cold air, and it is more dense than the warm air that the cold air is driving into, right? So the bigger the difference between the two air masses, the more dramatic the rise of the air. So you have to think of this cold air as kind of like a bully. The cold air is driving into the warm air, thrusting it up above the cold air. And when that happens, we get this massive cloud formation. The clouds that we're getting in this example would be an example of cumulonimbus clouds. Write that up here, cumulonimbus. And those cumulonimbus clouds bring thunderstorms, right? If this difference was less, let's say this was only 80 degrees and this was 85 degrees, we wouldn't have this cloud formation like this going on. It would be much less dramatic, and the weather would be less dramatic. However, in this picture, you might see something in real life look like this. This is an example of actual real life cumulonimbus cloud formation out in front of a cold front. So the cold front's moving in, and you have vertical development in this cloud. Remember, in thunderstorm clouds, you have massive updrafts and downdrafts, and that's where you get your severe weather. right? So this is an example of a real-life cumulonimbus cloud. So we've taken care of what the cold front would look like on a weather map, right, and on real life. Now let's take a look at what a warm front would look like and what happens with that. So here's our warm front picture. If we could take a look at the side of a warm front coming in, what we have is we have warm air, 85 degrees, moving over the back of cold air at 65 degrees. And I bet you know that that's because warm air is less dense than the cold air that it's moving into. So over the cold air, we're going to put more dense. When this warm air is moving towards the cold air, it has no choice but to ride up over the back of the cold air, right? What's cool about a warm front coming in is you can see physical evidence of this happening. If I draw me a house over here in the bottom left-hand corner and I'm there and I look up into the sky, very often what I'll see is I'll see these very thin, wispy clouds sitting up in the sky. We call these kinds of clouds mare's tails. These mare's tails tell us of a weather change that will be here within 24 to 48 hours. The scientific name for these mare's tails, of course, is called cirrus clouds. So where I see cirrus clouds, I can usually bet within 24 to 48 hours we're going to have a weather change. And that's because this less dense air is rising way up above the more dense cold air of this air mass that's already in place. As air rises, just like our low pressure systems, we have clouds form. So first we start with these cirrus clouds, then we get kind of a thin layer of clouds called stratus clouds. That's stratus here. And then eventually when we get down here near the bottom where the cold front and warm front meet, or the cold air and warm air meet, we can get what are called nimbostratus clouds. And these nimbostratus clouds can bring heavier rain. Now, generally speaking, the warm front passage is not as bad as a cold front passing, the type of weather. It's usually a little more of a gentle rain, but that's not always the case. Anyway, here's the warm front passing through. This is a picture that you might see of a warm front moving in. It's not a fantastic picture, but you can see the layered stratus clouds coming in. I wish this picture had some of those cirrus clouds I was talking about, but I couldn't find a good picture for it. But anyway, so you're not going to have massive building cumulonimbus clouds, right? You're going to get layered clouds. So this is the stratus clouds building up over the back of the cold air that's in place. So this is like a real surface feature map that you'll find on a weather station, weather guide, right? So what we have up top here where this L is we have a cold front moving through. So the cold air sits behind the front and it's moving this way, right? We have high pressure and control, high pressure and control. Remember where we have high pressure, we have nice weather, generally low-level clouds, right? Another cold front setting out here in the Atlantic Ocean. So this would be a real picture, right? Let's look at my example and talk about what we actually see going on. So with this one, we're going to try to put everything together. Look over here in the left-hand side. It says fronts are associated with low pressure systems. Remember that, right? We have changing weather for the worse or the rainier with low pressure systems. We don't have fronts ever with high pressure, right? So in our picture here, you see our low pressure system, and check our arrows out. Arrows are going counterclockwise, so this low actually rotates on the ground, right? And it's rotating counterclockwise. So what we get going on is we have this 65 degrees. This is the cold air sector. So there is cold air sitting back in this area. This is all cold air. And that cold air is moving into the warm air sector. So in front of this cold front, right, we have pretty heavy rain. We have quite a bit of rain coming down here because this cold air is driving into this 85 degree warm air. Then all of this area in here is nice and warm, having nice weather. This warm air is driving into what already is in place out here, this cold air. And so we have this repetition repeating over and over again. Something really important for you to realize is that the direction of the symbols of the symbols shows the motion of the front. So our front is moving this way. Cold front moves like this, and our warm front is moving this way. And I hope that makes sense, because if a low pressure rotates counterclockwise, that's what we should be seeing, right? The other thing that I want to talk about real quick on here is our high pressure. And our high pressure system, you see, is rotating clockwise. And there is good weather here then over Ohio, Indiana, Illinois, and Michigan. And we're in a good place right here, because remember, in a high pressure system, air is sinking. And if you have air sinking, you don't have clouds. So there. The very last thing, sorry, I got to do this to you, is the stationary front. This is one that's pretty important because it's another type of front. And a stationary front is a front that is just that. It's stationary. What we don't have is we don't have a driving force to move the front one way or the other. Basically, you have more of a longitudinal motion of the air. The air goes along the front rather than pushing the front. And so you get this stalled out. So where a cold front has the triangles on one side and a warm front has the half moons on a side, on a stationary front you have this, where they alternate one side on the other. And so this occurs when you don't have these driving forces, right? But this again is another kind of front that you'll see on a weather map and you could see on your test. So here there is no motion of the weather, so what you get is you get unsettled weather all along this front because it really doesn't have a driving mechanism. Anyway, there's that last one. I had to throw that in there for you. All right, good luck on your test.